Welcome to this ceremony to celebrate CERN's 70th anniversary. The ceremony will start in a few minutes. In the meantime, we invite you to discover the trailer of a film about CERN by French director Klapisch. It is a great privilege to welcome you to the CERN Science Gateway, our new science outreach and education centre inaugurated in October last year, made possible by the generosity of our donors. Bienvenue à cette cérémonie pour célébrer les 70 ans du CERN. La cérémonie va débuter dans quelques minutes. En attendant, nous vous proposons de découvrir la bande-annonce d'un film sur le CERN du réalisateur français Klapisch. C'est un grand privilège de vous accueillir au portail de la science du CERN, notre nouveau centre de sensibilisation et d'éducation aux sciences, inauguré en octobre de l'année dernière, rendu possible grâce à la générosité de nos donateurs.
La nuit, quand on regarde les étoiles dans le ciel, on se dit tous que l'univers est vraiment grand et compliqué à comprendre. Quand on regarde dans un microscope, on comprend qu'il y a aussi un monde dans l'infiniment petit et que celui-ci doit être bien compliqué à comprendre. À l'intérieur des cellules, on sait qu'il y a des molécules, puis des atomes, des électrons, des protons, des bosons. Le monde qui nous entoure, qu'on soit dans l'infiniment grand ou dans l'infiniment petit, est surtout infiniment complexe. Il n'y a qu'une seule population dans le monde qui ne pense pas la même chose que nous. Les physiciens.
La nature, dans sa beauté, dans sa complexité, en fait, elle est très belle aussi au niveau fondamental et elle est très simple. Donc, il ne faut pas faire les choses plus difficiles qu'elles ne sont.
Les gens qui pensent que l'univers est simple s'appellent des physiciens ou des chercheurs. Ils ne sont pas si nombreux. Ces irréductibles vivent dans un petit village caché entre la France et la Suisse, près de Genève. Ce lieu qui rassemble tous ceux qui comprennent ce que vous et moi ne comprenons pas s'appelle le CERN. Mon père a fait partie de ces gens-là. Il a travaillé ici pendant plus de 30 ans.
Qui comprend des éléments fissiles comme de l'uranium ou du plutonium ou d'autres actinides qui vont fissionner.
Mon père, c'est quelqu'un qui comprenait ça.
As a searcher, what are you looking for?
High-level research manicarco.
E dall'interazione con il campo tutte le altre particelle. Fundamentale Forschung zu betreiben.
Centralno mesto u standardnom modelu.
Sappiamo che c'è della materia strana. Onderzoek naar supersymmetrie.
Bon, la seule chose que je comprends, c'est que c'est pas si facile d'expliquer ce que font les physiciens. Ce qui est sûr, c'est qu'ils cherchent. Leur dernière bonne idée, c'est justement de créer un lieu destiné à tout expliquer. Ces physiciens qui tentent depuis 70 ans de simplifier la complexité du monde rêvaient depuis longtemps de ce portail de la science. Un lieu qui pourrait expliquer ce qui pour la plupart des gens est incompréhensible, un lieu pour transmettre les avancées actuelles de la science, un lieu pour expliquer les origines de la formation de l'univers. Et si nous on revient à l'origine de ce chantier complexe, tout a commencé il y a 3 ans par une particule élémentaire très simple, un cube en béton.
Voilà, c'est ça.
La première pierre.
Parfait.
Voilà, la première pierre posée. Merci beaucoup. Ce qui est spécial avec ce projet, tout d'abord, ce n'est pas un musée, c'est j'aime l'appeler un learning center, et un endroit où on apprend la science. Donc, c'est quelque chose de vivant et qui se trouve là où l'action se passe.
Renzo Piano est l'architecte de Beaubourg, du Grand Tribunal de Paris, du Shard à Londres, de l'aéroport international d'Osaka, et maintenant du portail de la science à Genève.
La beauté n'est pas visible, la beauté est cachée, est profonde. C'est ce qu'on peut dire à propos du CERN. La partie noble, incroyable, inimaginable du CERN est dans le sol.
À 100 mètres de profondeur, un mélange de tuyaux, d'aimants supraconducteurs et de capteurs forme une incroyable machine de 27 km de circonférence. C'est une des plus grosses machines au monde et le plus grand accélérateur de particules, le LHC.
Il y a un tunnel. C'est un peu comme s'il y avait 2 fragments de ce tunnel qui sont sortis de la Terre.
Le CERN sert aussi à créer des ponts, faire travailler des gens du monde entier, des gens avec des cultures différentes, des origines différentes, et donc contribuer à promouvoir la paix à travers la science.
Venir rencontrer les chercheurs, chercher moi aussi à mieux comprendre ce qu'ils cherchent, et donc ce que faisait mon père, me met en relation avec lui. Quand on les observe, on se demande comment ces scientifiques de l'infiniment petit voient le monde. Est-ce qu'ils peuvent tout résumer sous forme d'équations ? S'intéresser à ce lieu, c'est se confronter à des questions qui deviennent vite métaphysiques et vertigineuses. Comment s'est construit l'univers? C'est quoi le Big Bang? Le monde quantique? Comment est constituée la matière? Et c'est quoi ce fameux boson de Higgs?
C'est bien ce qu'on voulait. La lumière qui joue avec les grilles, avec les capteurs solaires. C'est quelque chose qui appartient à l'espace.
Mon fils Émile cherche encore ce qu'il veut faire, mais il aimerait devenir scientifique comme son grand-père. Je trouve ça émouvant de venir ici découvrir ce portail de la science avec lui. Trouver quelques réponses à des grandes interrogations, mais surtout continuer à se poser des questions. Aujourd'hui, il y a un lieu pour ça et pour mieux comprendre ce que cherchait mon père. Ce portail me permet d'entrer dans son univers. Ce que je n'ai jamais compris, peut-être que mon fils va mieux le comprendre. Je suis heureux de voir que lui aussi, il commence à chercher.
Ok, on y est. S'il vous plaît,
Congratulations.
Ciao bella.
Congratulations.
Grazie. J'aurais jamais raté ça. Malgré le temps, la météo. Italian? No. I'm learning. Conseil? Ah, c'est ça, oui. C'est dommage qu'ils ont pas entendu le speech. Je vais essayer d'expliquer la même chose avec Fabienne. Qu'est-ce qu'il y a? Eliezer? On commence. Eliezer n'est pas là?
La première institution supranationale, c'est l'Europe qui commence à s'unir. Les règles.
1949, Europe recovers from World War II.
Many eminent scientists have left for the United States and other countries.
European research is no longer world-class.
The visionary French physicist and Nobel Prize winner Louis de Broglie proposes the creation of a European laboratory that would be both a center of excellence in physics and a motor for peace.
His idea is taken up by American Nobel Prize winner Isidore Rabi, who together with Pierre Auger and Eduardo Amaldi convinced UNESCO to adopt this process.
18 months later, 12 European nations formally agreed to create the Conseil européen pour la recherche nucléaire.
The acronym CERN is born. Important decisions are taken in the first sessions of the new council.
Geneva is chosen as the seat because of its central location in Europe and its international tradition.
2 accelerators are put forward, the synchrocyclotron and a much larger machine, the proton synchrotron.
A new convention defines CERN's goal, stating that its research will have no concern with military requirements, and that all its results should be made public.
The CERN Convention is signed by 12 nations. Among the signatories are eminent physicists such as Werner Heisenberg.
CERN comes into existence.
Your Royal Highnesses, Excellencies, distinguished guests, ladies and gentlemen, welcome to this celebration of CERN's 70th anniversary. Vos Altesses Royales, Excellences, chers hôtes, Mesdames et Messieurs, bienvenue à cette célébration du 70e anniversaire du CERN. Depuis 70 ans, le CERN rassemble les nations du monde entier autour d'une quête fondamentale pour comprendre les lois qui régissent l'univers. Cette recherche a enrichi les connaissances de l'humanité et produit de nombreuses technologies avec un impact majeur sur la société. Today, CERN pursues its quest for knowledge with dedication and commitment and prepares a promising future of discoveries and innovations. Together, we will explore the major stages of this scientific, technological, and above all, human adventure. I am personally privileged to have been part of this human adventure for more than 20 years. My name is Anna Cook, and I'm honored to be your Master of Ceremony for this unique celebration. To officially open this ceremony, I invite CERN's Director General, Fabiola Gianotti, to take the floor.
Your Royal Highnesses, Excellencies, distinguished guests, ladies and gentlemen, dear colleagues and friends, it is with immense pleasure and pride, and no little emotion, I must admit, that I welcome all of you here today on this joyful occasion, and I'm humbly indebted to all of you for having joined us to celebrate CERN's 70th anniversary. Ensemble, nous allons retracer l'histoire extraordinaire de cette organisation extraordinaire et réfléchir à son futur. Let me start by emphasizing that CERN is a great success for Europe and its global partners and is a shining example of European excellence and competitiveness. CERN is the world-leading lab for high-energy physics and for the advanced technologies that our field needs and enable, and is much more than that. As we will see, CERN is a value system. Comme nous venons de le voir, le CERN a été fondé en 1954 sur les ruines de la Seconde Guerre mondiale, donc à un tournant crucial de l'histoire. Le laboratoire a été créé à l'initiative d'un groupe de responsables politiques et de scientifiques visionnaires avec le double objectif de rétablir l'excellence scientifique du continent après la guerre et de promouvoir la collaboration pacifique entre les pays et les peuples de l'Europe. En effet, nos fondateurs avaient compris que la renaissance de l'Europe après la guerre exigeait aussi des investissements soutenus dans la recherche fondamentale et que la science est une colle qui peut ressouder les pays et les peuples d'un continent fracturé. Today, CERN is a truly global laboratory with 24 member states, twice as many as in 1954, 10 associate member states, 4 observers, and many partners from all over the world, and a community of more than 17,000 people across more than 110 nationalities, an incredible melting pot of languages, cultures, traditions. For those of us who work here or have worked here, this rich and enriching diversity has become a normal part of our daily life. But in a world where conflicts between countries, religions, and cultures sadly persist, this is a truly precious gift which cannot be taken for granted. CERN's primary mission is research in particle physics. Particle physics underpins our understanding of the universe and how it has evolved from the initial Big Bang some 13.8 billion years ago up until today. It also underpins our understanding of the building blocks that make up the stars, the galaxies, the planets, life on Earth as we know it. Discoveries, measurements, observations made at CERN over the decades have made immense contribution to our understanding of the fundamental laws of nature and the structure and evolution of the universe. At the Large Hadron Collider, our flagship project, which actually runs physically beneath our feet, every day we are able to reproduce the conditions of the primordial universe as they were millions of a second after the Big Bang. Yet many open, crucial questions remain, as we shall see. For instance, 95% of the universe is dark to us, is made of forms of matter and energy that we cannot see or understand. And CERN is currently performing a feasibility study for its possible next facility, the so-called Future Circular Collider, which on the timescale of the mid-2040s may become the most extraordinary instrument humanity has ever built to understand and study the fundamental laws of the universe and address many of the open questions. Le CERN est aussi un moteur de l'innovation, car nos objectifs scientifiques très ambitieux nécessitent des instruments extrêmement complexes et sophistiqués et le développement de nouvelles technologies dans de divers domaines, matériaux supraconducteurs, cryogénie, vide, électronique, robotique, calcul et transmission de données à l'échelle planétaire, intelligence artificielle, informatique quantique. These technologies find application in numerous areas of society, and many of them have had a profound impact on our lives, from the World Wide Web to accelerators for treating cancer, the PET scanner and other medical imaging devices, superconducting magnets for medical and nuclear fusion energy applications. La formation est une autre mission cruciale du CERN. À tout moment, 4500 jeunes hommes et femmes sont formés ici, notamment des physiciens, des ingénieurs, des techniciens, représentant un large spectre de compétences. La plupart de ces jeunes poursuivent ensuite des carrières en dehors de la physique des particules, dans des entreprises, dans d'autres domaines de recherche ou dans des organismes publics. Donc, le CERN fournit à la société un flux continu de jeunes talents formés dans les domaines STEM, sciences, technologies, ingénierie et mathématiques, dans un laboratoire d'excellence scientifique et dans un environnement véritablement international. Je fais partie des dizaines de milliers de jeunes qui ont été formés ici, car je suis arrivée au CERN en 1994 en tant que jeune postdoctorante. Et pour moi, le CERN a été non seulement une très belle école de physique, mais aussi une grande école de vie. CERN founders will be so proud to see what CERN has accomplished over 7 decades of its life. And the aspiration and the values that motivated those founders are still firmly anchored in our organization today. They include the pursuit of scientific knowledge and technological innovation to the benefit of society, training and education, collaboration across borders, diversity, inclusion, and the great dose of boldness and determination to pursue paths that borders on the impossible. Donner les réponses aux questions vertigineuses dont parlait Cédric Klapisch dans sa bande-annonce. En conclusion, je voudrais remercier les États membres associés du CERN et tous nos partenaires du monde entier, ainsi que la communauté du CERN. Je voudrais rendre hommage à toutes les personnes qui ont travaillé ici au fil des ans et à tous ceux qui ont soutenu notre organisation d'une manière ou d'une autre pour avoir fait du CERN un lieu tellement exceptionnel. And I would particularly like to call on you, heads of states, governments, international organizations, ministers, other authorities, and in fact, all of you are here today. Please, please help us to ensure that CERN has a brilliant future. Places like CERN give us hope for a better world. Places like CERN show what humanity can achieve when we set aside our dispute and we focus on the common good. Des institutions comme le CERN nous donnent l'espoir d'un monde meilleur et nous montrent ce que l'humanité peut accomplir lorsqu'elle met ses différends de côté et travaille pour le bien commun. Merci. And now a short video illustrating CERN main scientific accomplishments. Let's watch it together.
Everything we see in our universe is made from fundamental particles. Its immensity is filled with microscopic mysteries.
For 70 years, CERN scientists have been working to unveil its secrets, making it the world's largest center for particle physics.
At CERN's foundation in 1954, scientists were trying to come to grips with the plethora of particles observed in nature.
They lacked an overall framework to explain these basic constituents of matter and the forces that act upon them.
This framework would later become known as the Standard Model, a very successful theory built on decades of experimentation and discovery.
Studying the infinitely small meant building experimental tools the size of monuments.
À Mérin, près de Genève, se trouve le plus grand chantier que l'Europe ait jamais vu. Il s'agit de la construction du Centre européen de recherche nucléaire.
In 1958, the SC, CERN's first accelerator, showed clear evidence of a rare particle transformation, the anomalous pion decay, which had been predicted by theory but never observed.
The PS first accelerated protons in 1959, becoming the world's most powerful accelerator.
In 1973, the Gargamel bubble chamber, which received a muon neutrino beam from the PS, proved the existence of weak neutral currents.
This major discovery solidified the foundations of the emerging standard model of particle physics.
In 1968, Georges Charpak developed the multi-wire proportional chamber, which revolutionized particle detection, heralding the electronic detector era.
Le prix Nobel de physique vous a été décerné pour votre invention et développement de détecteurs de particules.
This technology would later find applications in many fields, including biology, medicine, and security.
In 1971, the ISR, the first proton-proton collider ever built, revealed critical details about the strong interaction between quarks, marking another breakthrough in understanding the forces of nature.
The SPS was switched on for the first time in 1976. It was then transformed from a one-beam accelerator into a proton-antiproton collider.
This remarkable transformation led to a historic discovery in 1983, the W and Z particles, carriers of the weak interaction, for which CERN scientists Carlo Rubbia and Simon van der Meer were awarded the 1984 Nobel Prize in Physics.
The Large Electron-Positron Collider, LEP, was the largest scientific instrument ever built, and its tunnel, Europe's largest civil engineering project.
Within a few months of operation, LEP had already made one of its most important discoveries, the existence of exactly 3 families of quarks and leptons, crucial for understanding the deeper workings of our universe.
Over the next decade, LEP's precise measurements of nature's fundamental particles and forces put the standard model of particle physics on firm experimental ground.
The size of the LEP collaboration was many times larger than any previous experiment. This created the need for a new universal way of exchanging information, setting the scene for the invention of the World Wide Web, a tool which revolutionized not just science, but the entire world.
In 1995, at CERN's Lear facility, scientists brought together antimatter particles, forming the first atoms of antihydrogen.
In the year 2000, CERN announced the observation of a new state of matter known as quark-gluon plasma.
The state of matter prevailed for only a few millionths of a second after the Big Bang.
Today, the Large Hadron Collider is the world's most powerful accelerator, which stands as the result of an extraordinary scientific, technical, and human effort.
It was switched on for the first time in 2008, just 4 years before one of the most important discoveries in particle physics.
Zooming in this region.
The Higgs boson.
Well, I would like to add my congratulations to everybody involved in this tremendous achievement.
This year's prize is about something very small that makes all the difference.
In the wake of this groundbreaking discovery, the LHC's quest for knowledge deepens, unveiling particles that defy convention and challenge our understanding of the subatomic world.
With unprecedented precision, the LHC delineates the Higgs boson's identity, probing its mass, spin, and the subtle ways it influences other particles, seeking signs of new phenomena.
We peer into our universe's dawn through quark-gluon plasma, recreated in heavy ion collisions.
Yet, the universe keeps its secrets. Matter-antimatter imbalance, dark matter, dark energy, and hidden dimensions are just a few of the mysteries we have yet to uncover.
As we stand on the brink of tomorrow, the LHC's legacy paves the way for the next generation of accelerators.
We believe very firmly that to continue this search in the unknown, we will need a much larger accelerator at a much higher energy.
The journey is far from over.
Nous venons de voir que la découverte du boson de Higgs en 2012 est l'un des plus grands succès de l'histoire du CERN. En effet, cette particule très spéciale est liée au mécanisme qui a permis à la matière dont nous sommes tous constitués de se former dans l'univers initial, et donc qui nous a permis d'exister et d'être là aussi aujourd'hui. C'est grâce principalement aux travaux menés au début des années 1960 par les physiciens belges Robert Brout et Francois Englert et par le physicien britannique Peter Higgs que nous avons pu comprendre ce mécanisme. Peter Higgs nous a malheureusement quittés il y a quelques mois et nous pensons à lui aujourd'hui et à ses contributions décisives à la physique et à ses liens d'amitié avec le CERN. François Englert a enregistré un message spécialement pour cette cérémonie que je vous propose d'écouter.
In 1964, the Belgian theoretical physicist Robert Brout and François Englert, that's me, and the British theoretical physicist Peter Higgs proposed a theoretical mechanism, the Brout-Englert-Higgs, BEH. This can be viewed as a generalization of the known electromagnetic theory in presence of a massive particle. The new massive particle was discovered nearly half a century later at CERN in 2012, and the BEH mechanism was fully confirmed. I'm extremely grateful to CERN and to all the physicists who made the discovery after years of work. Merci à CERN et bon anniversaire.
Je remercie François Englert très chaleureusement pour son message qui me permet de souligner que la Belgique est l'un des 12 pays fondateurs du CERN et que ces instituts scientifiques ont participé à de très nombreux projets et expériences du laboratoire et ont ainsi contribué au moment clé de l'histoire du CERN. C'est un honneur d'avoir avec nous aujourd'hui Son Altesse Royale, la princesse Astrid de Belgique, qui représente Sa Majesté, le roi des Belges. Votre Altesse Royale, je vous invite à prendre la parole.
Ladies and gentlemen, distinguished scientists, researchers, and members of the CERN community, thank you for that wonderful video and the insightful interviews, especially with our fellow countryman, Nobel Prize winner Professor Englert. As someone who is not a scientist, but often visits labs, I am always amazed by what drives researchers to spend their time in sometimes less than glamorous environments. It's clear they are fueled by human curiosity. Today, as we celebrate CERN's 70th anniversary, we reflect on 7 decades of discovery, innovation, and collaboration, all sparked by the same curiosity. We are not just honoring an institution, we are celebrating a collective effort that has profoundly shaped our understanding of the universe. A heartfelt thank you goes out to the scientists and researchers here today, as well as those who paved the way before you. Your dedication and passion make CERN a beacon of knowledge. You dive into the unknown, seeking answers to life's fundamental questions about matter, energy, space, and time. Your work doesn't just expand our horizons, it also has a tangible impact on our everyday lives, especially in medicine. We know the life of a researcher can be filled with challenges and uncertainties. There are days when answers feel elusive. Yet, you keep asking, examining, and questioning. And when that moment of discovery finally arrives, when years of hard work yield a breakthrough, it must feel incredible. That rush of clarity and triumph is a powerful reminder of what human curiosity, ingenuity, and perseverance can achieve. Earlier today, I had the privilege of visiting CERN Large Hadron Collider. Walking through those halls, I was awestruck by the scale of groundbreaking experiments happening here. Meeting the Belgian scientists involved in this remarkable work was truly inspiring. Belgium is proud to support CERN, and I reaffirm our commitment to this exceptional European collaborative research project. Here's to 70 years of discovery and to the many more years of adventure driven by the CERN community's human curiosity. Le CERN est bien plus qu'un laboratoire. C'est le symbole de ce que nous pouvons accomplir lorsque les nations s'unissent pour la quête de la connaissance. Le CERN est voulu une initiative européenne permettant de garder nos grands cerveaux chez nous, créant ainsi un véritable pôle d'excellence scientifique, reconnu à l'échelle internationale. Il incarne le pouvoir de la collaboration avec des scientifiques qui travaillent ensemble, qui partagent leurs idées et qui repoussent les limites de nos connaissances. En tant que pays fondateur, la Belgique continuera de soutenir le CERN dans les années à venir, en contribuant à son succès grâce à nos nombreux scientifiques et experts. En élucidant le mystère de l'univers, il nous aide tous à mieux comprendre le monde, et c'est une mission que nous soutiendrons toujours. Pour conclure, félicitations pour cet anniversaire important de, comme on dit en Belgique et en Suisse, 70 ans. Je vous remercie pour votre dévouement et votre passion pour la découverte. L'avenir de la science est prometteur. Avec le CERN en tête, nous pouvons nous attendre à de nombreuses autres percées.
Votre Altesse Royale, je vous remercie. The European Union and CERN are united by a shared vision of fostering collaboration across European countries to achieve what no single country could accomplish alone. An observer to the CERN Council since 1985, the European Union has built a solid partnership with CERN, including areas such as research, but also training and education, medical, computing, and other technologies. I now invite Her Excellency Ursula von der Leyen, President of the European Commission, to take the floor.
Director General Gianotti, dearest Fabiola, Your Royal Highnesses, Excellencies, fellow leaders, distinguished guests. It is such an honor to celebrate with you the 70th birthday of CERN, together with some of the brightest minds in Europe and I would say in the world. Today, indeed, CERN is a magnet for top scientists from all continents. But as we just heard, there was a time when Europe was not at all an attractive place to science. 70 years ago, many of our most brilliant scientists had fled Europe. Others had put their research on hold. It was a handful of European physicists who turned the tide and brought science back to Europe. This is how the CERN was born. And indeed, Fabiola, as you said, your founders would be very, very proud of CERN today. Today, you are welcoming 17,000 visiting scholars every year. Basically, every physicist in the world wants to work at CERN. You have not only put Europe back on the map, you have become the center of the world for particle physics. And there's so much we can learn from your history. Just like 70 years ago, we live in times of rising geopolitical competition. We are in the midst of a global race for the technologies that will shape the world of tomorrow. From clean tech to quantum, from AI to fusion. And while Europe is home to more researchers than both the United States and China, we are losing ground in many fields. For instance, our global share of patent applications has been cut in half in the last 2 decades, from 30% down to 15%. It is time to turn the tide again, just like the CERN founders did 70 years ago. And today I would like to draw 3 lessons from the story of CERN. The first one is that scale matters. No European country alone could have built the world's largest particle collider. CERN has become a global hub because it rallied Europe. And this is even more crucial today, We are competing with giants. China is planning a 100-kilometer accelerator to challenge CERN's global leadership. Therefore, I am proud that we have financed the feasibility study for CERN's future circular collider. This could preserve Europe's scientific edge, and it could push the boundaries of human knowledge even further. And as the global science race is on, I want Europe to switch gear. To do so, European unity is our greatest asset. Horizon Europe is the largest research investment program in the world. Its crown jewel is the European Research Council that financed research that resulted in 14 Nobel Prizes. We must invest in this. And this is why I want to increase research spending in our next budget, just as you wished, Fabiola. But I also want to make it easier for you to access this funding. We have to focus our efforts on breakthrough innovation as proposed in the Draghi report. Our scientists must be able to find the researches and resources they need right here in Europe. This is a must, and we should focus exactly on this task. The second lesson of CERN is that if you want to compete more, you have to collaborate more. All your discoveries are open access. You proudly share them with a huge network of universities, industries, and startups. And it is in this spirit that we will propose a European Research Area Act. All European researchers should be able to access our world-class research infrastructure like supercomputers. It must be easier to pool expertise and computational power with no artificial borders or barriers. Europe's economy thrives because of free movement of goods, of talents, and capital across our single market. So, it is time to finally allow the free movement of knowledge and science all across Europe. And this leads me to the third lesson. Your core mission at CERN has always been fundamental research. But all along your history, you have produced countless positive spillovers for our society and economy. It is thanks to CERN that we have the World Wide Web. And Tim Berners-Lee is among us, as far as I'm informed, over there. Congratulations again to that. It is thanks to CERN that we have touch screens. It is thanks to CERN that we have new tools for fighting cancer. You are constantly working with European industries to build low-emission airplanes or to create new solutions to transport liquid hydrogen. CERN is the living proof that science fosters innovation and that innovation fosters competitiveness. We need more of these partnerships between research and business, more ideas that go from the laboratory to the factory, and this will be an important pillar of a new European Innovation Act. We must put research and innovation at the heart of Europe's economy. Ladies and gentlemen, when CERN was created, it seemed almost impossible to bring world-class science back to a devastated continent. When you designed a 27-kilometer underground tunnel where particles would clash at almost the speed of light, many thought you were daydreaming. And when you started looking for the Higgs boson, the chances of success seemed incredibly low. But you always proved the skeptics wrong. Your story is one of progress against all odds, just like the story of the Europeans. You were born to discover, and I cannot wait to see what you will discover next, because I'm sure that once again, CERN will change the world. Bon anniversaire, happy birthday, and long live CERN. Thank you.
President von der Leyen, thank you. Latvia's engagement with CERN has grown over the past years with participation in accelerator projects, the LHC experimental program, computing and education. In 2021, Latvia became an associate member state. I now invite Her Excellency Evika Silina, Prime Minister of the Republic of Latvia, to take the floor.
Dear Director General Fabiola Gianotti, Your Royal Highness, Head of Commission Ursula, Your Excellencies, Presidents, Ministers, dear guests. I'm honored here today to address you to mark the 17th anniversary of CERN. CERN has delivered many groundbreaking achievements through decades, and today CERN continues to play a vital role in research and development. Today, I had a chance to visit CERN's laboratory, to visit underground, and I must say, I am impressed and motivated, and I believe we need to show the world more what researchers and scientists and all of CERN is doing here. I am here to reaffirm Latvia's commitment to CERN because Latvia continues to respect CERN's principles of governance and values outlined in CERN's constitution. Through our participation, we aim to strengthen the organization and their discoveries. Latvia is a reliable partner of CERN. Partnership with CERN is one of ways how we see we can anchor ourselves in Europe, its research and development. CERN facilitates our integration into European research and innovative value chains. It is not just the Latvian government which supports CERN. I'm here with representatives of Latvian scientific and business communities, with those young generation which are eager to knowledge. They are innovative, dynamic, and increasingly engaged. Since Latvia became an associative member in 2021, CERN has had a positive impact on our science and business communities as well. More students, researchers, and companies can share knowledge and get access to modern science at the European level. And that is what is CERN about, right? Isn't it so? Ladies and gentlemen, our partnership is mutually beneficial. It contributes to development of research and science potential. Scientific output of our top universities and research institutions has increased. Interest of students to study physics has increased as well. CERN gives cutting-edge learning tools to teachers who promote pupils' interests in physics, engineering, and STEM subjects. Because CERN facilitates not only international scientific cooperation, but also collaboration among domestic scientific and business communities, and that it is what we all want in Europe to boost up our competitiveness. This partnership also gives access to programs and capacity building measures, as well to achieve more and dream big. CERN becomes available to an increasing number of students, fellows, researchers, and associated staff. It gives access to CERN procurement opportunities. Scientific discoveries become increasingly available for real-life applications. However, they need to go beyond practical physics. Our vision is to do more in the areas of medicine and cleaner environment. As an EU member state, we believe that CERN should have a more prominent place in EU programs. And what we all heard, it is proposed. And CERN is our lab. Latvia is committed to becoming a full-fledged member state of CERN in 2027, we hope so. And we remain ready to open to new opportunities of CERN's potential and our partnership. And one more time, congratulations on your 70th birthday.
Thank you, Prime Minister Silina. Several thousand students and young graduates are trained in CERN's unique scientific, technical, and multicultural environment. We will now hear the voices of this new generation of scientists with 4 testimonies from young researchers. We will then welcome the Orchestra de la Suisse romande under the baton of conductor Zofia Kiniorska, who will perform Gabriel Fauré's La Pavane, Opus 50.
Hello, I'm Jorinda, I'm from the Netherlands. When I was a student in Leiden, I got intrigued by the physics of elementary particles, by questions about the origin of our universe and its fundamental building blocks. I dreamt that one day I could be a researcher in that field, and now that dream has become my everyday reality. I work on understanding the history of the universe and how we can use cosmology to learn about physics beyond the standard model of particles. What is special about CERN is not just the science, but it's also the atmosphere. Being here, surrounded by smart and curious minds from all corners of the world, all trying to understand what our universe is made of, is very inspiring. It is a reminder that science has no borders. We all share the same curiosity and drive to learn and expand human knowledge. I hope that we can continue this journey together, and that CERN will remain a place where future generations can keep chasing and hopefully answering these big questions.
My name is Philip. I'm a physicist from Germany working on the ATLAS experiment. The ATLAS detector is right next to you, 100 meters below your feet. It allows us to measure the known elementary particles with great precision and to explore the unknown. You heard about the Higgs boson. Perhaps there exist additional Higgs bosons we have not discovered yet. My colleagues and I searched for Higgs bosons that could decay into top quarks, the heaviest particles, using the same advances in artificial intelligence that revolutionize our digital society. Working on problems like this is incredibly rewarding, and doing it at CERN, surrounded by brilliant minds from all over the world, is an experience unlike any other. I know that CERN will continue to be a place where science comes first, and that our curiosity will fuel CERN for the next 70 years and beyond.
Hello, my name is Valeria, and as a child growing up in Ukraine, I watched a documentary about the commissioning of the Large Hadron Collider. Fascinated by the complexity of the machine, I promised myself that one day I would work here. 10 years later, when I came to CERN for the first time, I realized I had found my place. And since then, I have kept returning and being more and more involved in the LHCb experiment. I moved across the countries, maintaining my close bond with CERN. I started as a Ukrainian intern, then pursued my PhD in France, and now I'm a postdoc in the UK working on beauty quarks as a part of our effort to understand matter-antimatter imbalance in the universe. What makes CERN so special to me is that it offers an opportunity to do fundamental research while working on cutting-edge technologies alongside people from all over the world.
Hey, I'm Anton from Sweden. Before I joined CERN, I never thought that one could work here as an engineer. Yet here I am today, working as a doctoral student in data science and engineering physics to automate the operation of our particle accelerators. Being at CERN has been an incredible experience for me, not only through the professional collaborations, but also by meeting people from diverse cultures and disciplines. I have also been able to connect with many young minds from outreach activities that I can inspire to explore the exciting possibilities in the world of science and engineering. I feel privileged to experience these opportunities and hope CERN continues to inspire and empower future engineers and scientists, giving them the tools to collaborate and innovate on a global scale. Happy birthday, CERN.
Please welcome the Orchestra de la Suisse romande's conductor, Zofia Kiniorska. Merci. As the musicians take their leave, please join me in a final round of applause. Thank you. Thank you for your patience while we prepare the stage. The Slovak Republic became a member state in 1993. Today, Slovak contributions to research in high-energy physics focus primarily on the LHC experimental program, with notable contributions across many other physics projects. I now invite His Excellency Peter Pellegrini, President of the Slovak Republic, to take the floor.
Madam Director General, Mr. President of the Council, Your Royal Highnesses, Excellencies, ladies and gentlemen, friends of science. I would like to express my thanks to the leadership of CERN, especially to you, Madam Director General, for your vision and dedication. It is your leadership that made possible the Science Gateway Visitor Center and the preparations for the FCC project. Signora Gianotti, lei è una vera ispirazione. I would also like to thank the outgoing Council President, Professor Rabinovici, for his endless creativity and for always being an honest broker in difficult times. Toda Raba. And my gratitude also goes to CERN host states, France and Switzerland, for their ongoing support and continued commitment. 70 years ago, Europe was still recovering from the horrors and scars of war. The world had just witnessed the devastating power of the atomic bomb, one of the humanity's darkest hours. We stood at a crossroads. In Paris, a group of visionary scientists, men and women, wanted to transform the same power into a force for peace, knowledge, and cooperation. These great minds knew science unites people across borders, and that idea became CERN. Today we stand where once was just a vision, discovery instead of destruction, one of humanity's brightest hours. This brilliant institution pushed the boundaries of human knowledge. The discovery of the Higgs boson is just the tip of a pyramid of what the CERN has done for the mankind. We know already so much, and yet still so little. The true nature of the universe remains a riddle. We still have some more questions than answers, and those too raise new questions. The future lies ahead of CERN is ready to take the next leap. The Future Circular Collider project has the potential to be more powerful, more complex, and more useful than anything before. If the Standing Colliders was a magnifying glass or the moon landing, the FCC would be the Webb Space Telescope shooting us straight beyond our galaxy. Will we find new particles, unusual forms of matter? Will we prove or disrupt the standard model? I don't know. Nobody does. But does it really matter? If you think of all the useful technology in innovation that we all use daily, thanks to the science made here at CERN, I don't need a promise of the next big thing or some catchy sales pitch point of reference to believe. Believe that wherever the FCC may take us, the journey will certainly bring myriads of great breakthroughs, and that every cent invested will pay off multiple times and benefit us all. It will bring us closer to a world where everybody has access to and profits from technology, no matter where they are born. The scale is huge, the potential boundless, and the challenge, we should accept it. We should embrace it. We should actually run towards it. Honestly, Europe is rather slow and hesitant, burdened by complicated history, tradition, and bureaucracy. But the competitive world around us isn't revolving at a slower pace. But it's also true that when Europe unites, we are capable of incredible things. CERN, as the world's undisputed and long-term #1 in particle physics, is a living proof of that. Let us remember that we've already done this before. Founding CERN seemed unthinkable, and yet here we are. It was our unity and determination that made the vision a reality and achieved things once unimaginable. Today we face a similar challenge, but we also have 70 more years of trust, experience, cooperation, and success on our side. Do we need the future circular collider? My inner science screams yes. Yes, we do. What we need to do now is to make the politician in us, often limited in thinking by our election terms, become true and mature leaders with long-term vision and win our voters over for this project. That is our only job. The much harder one will be handled by our scientists, engineers, and businesses. So don't let us fail them. Together we can make this happen, inspire and enrich many generations to come. Let's continue to explore the unknown. Let's keep seeking the truth. It has always been through science that we are the closest to it. The FCC is not just CERN's or Europe's project, it's the world's project. And why not show the world that 70 years ago, or 70 years on now, we can still work together for peace. I would say amen, but I rather say, let the Higgs boson guide us wisely, and thank you.
Thank you, President Pellegrini. C'est ici, en Suisse, que le CERN a commencé à bâtir son histoire en 1954. État fondateur et l'un des 2 pays hôtes avec la France, la Suisse a fourni un soutien sans faille à l'organisation, tissant des liens très forts en physique et dans bien d'autres domaines, dont les applications ont des retombées importantes pour la société. J'invite son Excellence Viola Amherd, présidente de la Confédération suisse, à prendre la parole.
Madame la directrice générale, Vos Altesses royales, Excellences, Mesdames et Messieurs, nous fêtons aujourd'hui le 70e anniversaire d'une organisation remarquable, le CERN. Ce centre de recherche étudie les plus petites composantes de la matière. En tant que juriste, mes connaissances dans ce domaine sont assez limitées. Comme j'habite un canton de montagne, je suis en effet plus familière des hauts sommets que des particules élémentaires. On peut dire cependant que, depuis sa création, le CERN aussi atteint des sommets, puisqu'il a accumulé du savoir et créé un nouveau paysage scientifique. Ces découvertes importantes sont l'héritage de tous les collaborateurs et collaboratrices passés et présents du CERN. Nous vous devons des découvertes fondamentales en physique et des applications que nous utilisons tous les jours. Je pense en particulier à l'Internet. En tant que président de la confédération, je suis fière que la Suisse soit membre fondateur du CERN et l'un des États hôtes et que mon pays ait pu contribuer ainsi au progrès de la science. L'institution que nous célébrons en ce jour symbolise la soif de connaissance de l'humanité. Elle est également un très bon exemple des succès qu'obtiennent les États qui ne travaillent pas les uns contre les autres, mais ensemble. Le CERN a créé à une époque où l'Europe était animée d'un tel esprit de coopération et formait l'espoir de progrès commun. Non seulement notre continent, mais le monde entier a urgemment besoin de cet esprit. La Suisse est extrêmement reconnaissante et de la collaboration entre les États ici présents qui soutiennent le CERN et tout particulièrement de la collaboration avec l'autre État hôte, notre partenaire, la France. Je tiens également à saluer le soutien indéfectible qu'apporte depuis 70 ans Genève et l'ensemble de la région qui l'entoure. La Suisse mettra tout en œuvre pour que l'organisation puisse se développer au mieux à long terme. Cet objectif figure noir sur blanc dans notre stratégie de politique extérieure pour les années à venir. Le Parlement fédéral à Berne vient d'amender une loi qui donne à la Confédération la compétence d'approuver les constructions du CERN sur le sol suisse. L'importance stratégique du CERN sous l'angle de l'aménagement du territoire correspond désormais à celle des aéroports ou de l'infrastructure ferroviaire. L'excellence, mesdames et messieurs, nous vivons une époque marquée par la désinformation et les fake news. Le CERN est d'une certaine manière à l'opposé de ces procédés, puisqu'il vise à acquérir de vraies connaissances en collaborant par-delà les frontières. Il nous faut aussi relever que les progrès qui sont faits ici, au CERN, au cœur de l'Europe, profitent au monde entier. De tout cœur, donc, je vous dis merci.
Madame la Présidente, je vous remercie. This celebration reminds us that fundamental science is not confined to laboratories or to the blackboards of theoretical physicists. It shapes our world, touching every aspect of our lives. The video you are about to see speaks of CERN's enduring legacy and its continued commitment to driving innovation, education, and international cooperation.
More than 400,000 years ago, our ancestors first approached fire, realizing that it kept wild animals at bay.
Through exploration and curiosity, prehistoric people came up with imaginative ways to use fire for protection, heat, light, food preservation, and social gatherings.
For most of human history, we have used multiple applications of fire to generate light and heat.
What brought us illumination at the flick of a switch? It certainly wasn't the development of candles. Today's world, dominated as it is by faster and faster pace of new technologies, is the result of a revolution in physics that started at the end of the 19th century.
Maxwell's laws of electrodynamics led to electric power, radios, and television.
Thomson's Nobel-winning discovery of the electron led to modern atomic physics and set the stage for the development of quantum mechanics, opening up the era of electronics.
New scientific theories, concepts, and discoveries proliferated and brought about cataclysmic transformations of the world at all levels: technological, social, and cultural.
Created in 1954 by some of the protagonists of the 20th century physics revolution, today, CERN carries the torch of the virtual circle of knowledge and innovation at an accelerated pace.
As distant as it might seem from our daily lives, particle physics has always been a trailblazer for disruptive technologies that benefit society.
The invention of the World Wide Web, facilitated by the laboratory's unique collaborative environment, is one of the striking examples.
The unprecedented scale and technical requirements of the accelerators, detectors, and computing infrastructure that particle physicists need for their research has constantly pushed the boundaries of technology.
Today, there are over 40,000 accelerators around the world. Only 3% of them are used for fundamental research. The others are in industry or in hospitals to treat patients.
The complex detectors built by physicists to study nature in its finest details have fueled new developments in many fields, from medical imaging to security, all the way to space exploration.
To cope with the huge amount of data generated by the collisions at the heart of the LHC detectors, scientists are constantly pushing the limits of computing technologies. Today, the worldwide LHC computing grid links up around 170 computing centers in more than 40 countries.
CERN's expertise in machine learning and AI techniques also has the potential to address complex problems, such as environmental monitoring across large areas, understanding and mitigating the impact of air pollution,
developing self-driving vehicles, and supporting doctors in making fast and accurate clinical decisions.
Since its foundation, CERN has stood as a model for international collaboration and is today a truly global laboratory with over 17,000 people from 950 institutions in more than 80 countries, serving as an inspiration to people around the world.
The latest example is Sesame, the first synchrotron light source set up in the Middle East on the model of CERN. In line with its commitment to open science, CERN developed SCOPE,
a pioneering collaboration with thousands of institutions worldwide,
converting high-energy physics journals to open access. At any given time, about 4,500 young scientists and technologists are being trained in cutting-edge research at CERN. Such a full immersion in the laboratory's unique environment prepares them to drive innovation and progress in academia and industry.
This continuous flow of young talent is one of CERN's most significant contributions to society.
By upholding the values of excellence, openness, and inclusiveness on a global scale,
CERN will continue to advance science and technology
for the benefit of society.
Serbia's involvement in CERN's scientific community is long-standing, with Serbian scientists contributing to numerous experiments and collaborations at the organization long before the country joined officially as a member state in 2019. I now invite His Excellency Aleksandar Vucic, President of the Republic of Serbia, to take the floor.
Your Royal Highnesses, Madame Gianotti, dear Ursula, I have good speech writers, but I'm not going to read it. What can I say after all these people in a relatively different way? I wanted to say congratulations to CERN, happy to be able to represent the country that is a full-fledged member state of CERN. Many of Serbian physicists and engineers, around 80, were coming, and still they work very diligently here for CERN. And now I'm going to raise one issue, because I believe this is important, and I'm finishing within 2 minutes. Madame von der Leyen, you were speaking about some numbers. I can tell you that we are facing huge problems in my country regarding education. And yes, we learned a lot from Ursula from Switzerland about the dual vocational system. But still, in the era of artificial intelligence, production of electric vehicles, we won't be able to produce enough electricity in the future if we don't get nuclear modular reactors to our country. And how we can do it, because we have each year less and less nuclear physicists, nuclear engineers. At the same time, we are losing an entire faculty of mining and geology because it became so weirdly unpopular of this fashion green and all the other movements. And I don't know what we're going to do, but I see that many of our numbers, when I say it, I'm not speaking only on behalf of my country, I'm speaking on behalf of an entire Europe because I see it. Many of our numbers are plunging. Chinese numbers are soaring. They have an eye of a tiger. We don't have it. We all act in a bit spoiled way, like everything's fine, everything's good, and everything will be better. CERN is the best example of what you did mainly. We just joined you, but I'm begging you just to see what we can do, and we need to do much more in order to survive. And at the end, as I promised, Ursula was saying the best news to you, Madame Gianotti, which means that they're going to raise more money for CERN, and we are a small contributor, but paying regularly all our obligations. We are going to double the level of money that we're going to contribute to CERN. This is still going to be insignificant comparing to what Ursula promised to you, but if all the others would do the same, that would be not that insignificant. Thank you very much.
Thank you, President Vucic. Cooperation between Bulgaria and CERN started in the 1980s, and the relationship has continued to grow ever since, spanning CERN's scientific program. Bulgaria became a member state in 1999. I now invite His Excellency Rumen Radev, President of the Republic of Bulgaria, to take the floor.
Dear Director General, Your Royal Highness, Excellencies, dear members of the scientific community, here, ladies and gentlemen, it is a pleasure to be back here and to witness the huge progress done for the last 5 years. This is why I would like to express my deep gratitude to the Director General, Fabiola Gianotti, and her dedicated team for the courageous vision, for the hard work and dedication to implement that vision, and prominent leadership. So we highly appreciate. And I'd say that the value of CERN expands far beyond a scientific center for advanced, cutting-edge research here. CERN is a brilliant example of how far we can go if we unite our efforts for the benefit of humanity. CERN is the place where the cooperation between science, education, and research and business delivered best results. And CERN is a sound implementation of the new vision of the European Commission to develop sustainable competition and clean industrial deal through research and innovation. And moreover, and the most important for me, CERN is, and CERN has become, an inspiration for our young people and a model for the future. This year we marked the 25th anniversary of Bulgarian
admission as a full-fledged member of CERN. And since 1990, our prominent scientists have been actively involved in the most ambitious projects developed here. And the substantial contribution of our researchers in the leading experiments is notable. And moreover, I'm sure I spoke to many of them. They are ready, and they have been working on the future large-scale experiments like the search for hidden particles. And our researchers, together with their counterparts from the neighbor countries, from the region, they are the driving engine for the establishment of International Research Institute for Sustainable Technologies in the Southeast Europe. But I would like also to use this opportunity and to mention the heavy involvement of the Bulgarian industry in this project. Why heavy involvement? The copper plates of the SPS accelerator at the total weight of 700 tons are produced in Bulgaria. And as well as hundreds of specialized cameras and a lot of other specialized equipment. I was given a full list of this equipment, but believe me, it is difficult to read, even not to understand. So I gave up, absolutely. One of our strong sides, this is the development of software and integration of this very complex equipment. This is why I would like to take this opportunity and to express, as a President of Bulgaria, my deepest gratitude to the community of over 100 Bulgarian scientists, engineers, and technicians fully dedicated to this organization. However, CERN and our cooperation with CERN extend far beyond its scientific endeavors. We highly appreciate the CERN's educational initiatives, which deliver a wide range of opportunities for our teachers, students, and young researchers. Over 800 Bulgarian teachers have undergone training in this organization. And this invaluable experience delivers for them the necessary skills, knowledge, and inspiration to cope with the challenges of the future. And I truly believe that the breakthroughs achieved here will continue to profoundly impact our abilities to build a better world. And that's why I can assure that Bulgaria will remain fully committed to this organization. I would like to join to Aleksandar's concerns about the industrial future of Europe, but last year was crucial as the Commission and the Council, they adopted the critical raw materials act. So Europe is waking up. We cannot afford anymore this luxury to import cheap resources from somewhere and to outsource our mining industry and to outsource our heavy industry. So I truly believe that uniting our efforts under this vision, it's time to wake up, because the world has become a cruel arena of competitiveness, and we must really wake up and work together. Happy birthday. Thank you.
Thank you, President Radev. In the past 70 years, great progress has been achieved, yet nature holds many mysteries still that inspire ever greater experimental efforts to unveil them. Let us now look ahead with a video that invites us to be inspired by the vision of CERN's future, a future where our collective efforts will continue to deepen our understanding of the universe.
Particle physics seeks to understand the inner workings of the universe by dissecting it into smaller and smaller components.
Uncovering the laws of nature in the form of mechanisms, structures, and interactions.
It's a stunning fact that all these laws can be described using the language of mathematics.
And that the physics at the smallest scales is related to the physics at cosmic distances.
Major breakthroughs were made when physicists realized how seemingly unrelated phenomena could be described using the same mathematical laws.
In fact, they simply turned out to be different manifestations of the same law of nature. In 1687, Isaac Newton unified the force that causes everyday objects to fall with the force that holds celestial bodies in their orbits. The law of universal gravitation was born.
In 1865, James Clerk Maxwell realized that electricity, magnetism, and light could all be described together in one unified theory, electromagnetism.
Then, in the early 20th century, quantum mechanics and Einstein's theories of special and general relativity revolutionized the way we see the world.
Today, the standard model of particle physics unifies two of the four known interactions, the electromagnetic and the weak force, into a single electroweak theory.
And describes the third interaction, the strong interaction, using the same mathematical framework.
Over the last 70 years, through studies of particles and their interactions, CERN has played a pivotal role in establishing the standard model as the most accurate description of the laws governing the smallest building blocks of our universe.
But this description is far from complete.
Incorporating gravity, the fourth fundamental interaction, in the mathematical framework of the standard model remains an outstanding challenge.
In addition, there are several features in the standard model that arise without an explanation.
The fundamental building blocks of matter are 6 quarks and 6 leptons, organized into 3 families, with the first one making up all stable matter.
But the reason for having exactly 3 families remains a mystery.
The mechanism that gives particles their masses was confirmed by the discovery of the Higgs boson in 2012 and the studies of its properties that followed.
But the mechanism doesn't predict the values of these masses. We can measure them, but we can't explain why they take exactly these values.
The Higgs boson itself leaves many questions open. One fundamental mystery is, what mechanism caused the Higgs field to uniformly and persistently fill the universe?
Puzzles such as these inspire new theories beyond the standard model and extensive experimental studies of the Higgs boson.
But there are also phenomena that we observe that the standard model simply cannot explain.
The Big Bang should have created equal amounts of matter and antimatter particles. But today, all the stars and galaxies appear to be made only of matter. So, where has all the antimatter gone?
In addition, those stars and galaxies, and all matter that we know, only account for 5% of the energy and mass in the universe. Around 27% of it seems to be made up of a mysterious substance that we call dark matter.
The origin of the remaining 70%, a form of energy causing the universe to expand faster and faster, is one of the greatest mysteries in physics.
So, what is the next step? Colliding particles at higher and higher energies allows us to create, observe, and study new particles and phenomena that would otherwise remain beyond our reach.
CERN is currently studying the Future Circular Collider, an instrument that may revolutionize our understanding of particle physics. Relying on novel accelerator technologies, it offers a unique opportunity to further investigate uncharted territory with a powerful long-term plan for 21st century particle physics.
Together with faster, more sensitive detectors and revolutionary computing infrastructure,
the next generation of accelerators could bring us closer to making our universe a bit less mysterious.
Italian scientists and engineers have made strong contributions to all important projects that have marked the history of the laboratory since its foundation 70 years ago. One of the founding member states of the organisation, Italy has consistently played a crucial role in advancing CERN's multifaceted mission. I now invite His Excellency Sergio Mattarella, President of the Italian Republic, to take the floor.
Signora Direttrice Generale, autorità, illustri partecipanti, sono davvero molto lieto anch'io di intervenire in questo 70° compleanno del CERN, motore di progresso scientifico ed esempio di quanto il linguaggio universale della scienza significhi apertura, superamento delle barriere. Una circostanza ben chiara al gruppo di scienziati che negli anni immediatamente successivi alla Seconda Guerra Mondiale promosse la istituzione del CERN, divenuto nel tempo, oltre che un centro di ricerca di eccellenza, una rete che unisce 10.000 ricercatori e centinaia di atenei nel mondo. Uno sguardo al futuro, una scommessa di speranza per un'Europa che, uscita dilaniata dalla guerra, aveva anche visto piegare la scienza al servizio di cause contro l'umanità. Nei lavori preparatori allo statuto del laboratorio, i padri fondatori tennero a sottolineare che nessuna delle ricerche condotte al CERN sarebbe potuta essere motivata da scopi militari e che ogni risultato sarebbe stato liberamente accessibile a tutti. Il CERN, da allora, ha continuato ad accentuare questa sua caratteristica di luogo di incontro, di scambio e di crescita per scienziati e ricercatori provenienti da ogni parte del mondo, che qui vengono a studiare, a formarsi nella consapevolezza che la cooperazione rappresenta reciproco arricchimento. Con grande afflizione si è assistito alla scelta della Federazione russa di riportare la guerra nel cuore d'Europa con l'aggressione all'Ucraina, con conseguenze severe sul terreno della cooperazione scientifica. Il Centro Europeo per la Ricerca Nucleare è sempre stato testimonianza della volontà di costruire un futuro comune, non compatibile con chi antepone la forza delle armi al dialogo e alle ragioni del diritto. Costruire la pace attraverso la scienza, questa la vocazione del CERN, punto di riferimento mondiale nella ricerca sulle particelle elementari, con straordinari risultati che ci aiutano a guardare al mondo e al suo funzionamento in modo più consapevole e che sono al tempo stesso determinanti per il nostro progresso e per il nostro benessere. Basti pensare alle applicazioni in settori quali la medicina. Il merito principale di questa storia di successo va ovviamente ascritta alla comunità dei ricercatori che opera giorno per giorno in questi laboratori. Una storia cui la Repubblica Italiana ha fornito un convinto contributo. Alcuni grandi fisici italiani hanno partecipato alla sua guida: Edoardo Amaldi, al premio Nobel Carlo Rubbia, a Luciano Maiani. E mi rivolgo adesso a lei, signora direttrice, prima donna chiamata a rivestire questa delicata responsabilità. Le strutture di ricerca italiane si sono avvalse positivamente del rapporto con il CERN e sono certo che questo dialogo continuerà a essere fattore di elevato arricchimento reciproco in campo scientifico e in aree di grande specializzazione, quali i magneti superconduttori e le nuove tecniche di accelerazione delle particelle. Questi luoghi recano anche altri segni del contributo italico. Grazie a Renzo Piano, qui la bellezza architettonica si fa interprete dell'incontro fra scienza e società. Signora direttrice, nell'esprimere apprezzamento per i risultati che il Centro Europeo di Ricerca Nucleare ha saputo conseguire in questi suoi primi 70 anni, desidero segnalare come il CERN abbia rappresentato e rappresenti un esempio virtuoso di cooperazione europea in una realtà globale segnata anche in ambito scientifico da potenze di scala molto superiore agli orizzonti nazionali. Progredire significa impegno comune perché il CERN possa continuare a esercitare il suo ruolo di eccellenza, contribuendo alla leadership europea in un settore chiave per l'autonomia strategica del continente, anche attraverso scelte coraggiose, come quella del nuovo grande progetto qui elaborato, indispensabile per mantenere protagonismo scientifico che tante positive ricadute ha per i nostri concittadini. A tutti voi del CERN, agli scienziati che ne sono parte protagonista, va l'augurio più intenso di un futuro sempre brillante. Siete voi stessi degli acceleratori di progresso scientifico, di ricerca di un bene comune che sa guardare oltre i limiti ristretti degli interessi locali, proiettato verso il riconoscimento di un destino condiviso dall'umanità.
Thank you, President Mattarella. We have so far journeyed far and wide with inspiring accounts from some of CERN's member and associate member states and observers. In this final speech, we will hear the perspective of the CERN Council, CERN's supreme decision-making body. I now invite Professor Eliezer Rabinovici, CERN Council President, to take the floor.
Dear Director General Fabiola Gianotti, dear members of the CERN Council, the member states, the associate member states and observers, dear CERN staff, and dear CERN users. Okay, that part was easy. Now comes the part of how to be original after everything which was said. And my attitude, the attitude I'm going to take is that what was so special and can happen here at CERN is that actually in English, in French, and in Italian, we heard the same thing. That is, we all spoke here in one voice. And this is not the usual situation. So I'm going to continue in this one voice. We are here to celebrate the 70th birthday of CERN. I wish on behalf of the CERN Council to recognize its vision and accomplishments, emphasizing the message of hope it carries. Hope is something we need so dearly today. 70 years is a time to reflect on the past and on the future. Imagine the period of 1947-1954 when CERN was conceived. World War II is just over. Large parts of Europe and Asia are still recovering from ruins, while a Cold War is present and the fear of a nuclear confrontation is everywhere. There are wars in Asia, in the Middle East, and Africa. And yet, 12 European countries have a daring joint vision to invest in a new world laboratory in which past enemies will collaborate for the good of humanity. Moreover, the most advanced knowledge will be shared among scientists of both sides of the war. There are so many arguments why not to invest in such a vision. Indeed, it seems a completely unrealistic vision, if there ever was one. But it turned out to be one of those few and so valuable realistic dreams. Let's elaborate. Science and technology. At the period, CERN was not even a clear number 3 in the world of nuclear and high-energy physics, led by the United States and the Soviet Union. After 70 years, CERN, and through it Europe, is the world leader in the field. It has laid many of the experimental foundations for the most advanced basic human scientific understanding embodied in the standard model of the three basic forces. It has become the world leader of the technological breakthroughs needed to make the discoveries at CERN. Actualization of a good, realistic dream gives us hope. The human aspect. It has highlighted the more positive qualities of humanity, its curiosity to understand the world around it and to be able to develop the tools needed for this. It is a unique place where people come to give and not to take. CERN has become a unique ecosystem where scientists from all over the planet work together for humanity. It demonstrates humanity's ability to do so. As humanity faces in the coming decade challenges that will require real international collaboration on a large scale, CERN gives us the hope that this is possible. I am moved time and again when I watch thousands of people who can't agree on the best rock star or the best football team build together the most complicated of machines, and the machine actually works. Thanks to the commitment of the member state, associate member states, observers, users, CERN staff, and a long line of director generals, of which Fabiola is now the current one, CERN has achieved leadership for Europe, and with leadership comes responsibility. CERN Council and management are now working together hard to forge the future of CERN. I was very encouraged, especially to hear from the President of the European Union, a strong vision for CERN. Science needs CERN, humanity needs CERN, and so does Europe. We are here together celebrating the past, present, and future of this adventure. We are celebrating hope.
Thank you, President of Council. Nous arrivons à la fin de cette cérémonie qui a retracé 70 années d'avancées scientifiques et technologiques et esquissé les grandes lignes d'un avenir scientifique qui s'annonce passionnant. To conclude this celebration, I invite our Director General, Fabiola Gianotti, to say a few final words.
Your Royal Highnesses, Excellencies, distinguished guests all, I wish to thank you for coming to CERN today, despite the weather. En fait, à chaque anniversaire, le temps est moche. Le 50e, il pleuvait des cordes, donc c'est... And I wish especially to thank you for your great contributions over the years in your countries, in your institution, in your laboratories, in your foundation, in your films, in your organization, to the great success of CERN. I think we can all be proud of CERN has accomplished over the years, and I think it's true to say that reality has exceeded the wildest dreams of our founders. It is now our duty to propagate those dreams into the future and make sure that this unique institution, our unique institution, continues to be a precious asset of humanity for many decades to come. Qu'est-ce qu'on va dire en conclusion, Anna?
Joyeux anniversaire
au CERN et à vous tous.
Happy birthday
and thank you very much.
Thank you. Thank you. Thank you so much. Thank you.
CERN is a great success for Europe and its global partners, and is a shining example of European excellence and competitiveness. and a community of more than 17,000 people across more than 110 nationalities, an incredible melting pot of languages, cultures, traditions. For those of us who work here, or have worked here, this rich and enriching diversity has become a normal part of our daily life. But in